begin our first session, and our speaker is Mr. Rahul Puri, who is the CTO and Head of Regulations Network Infrastructure India at Nokia. He leads the technology strategy and regulatory engagement, driving innovation across next generation network infrastructure, AI-enabled connectivity and digital transformation initiatives. With extensive experience in telecommunication, Rajan works closely with the industry stakeholders and policymakers to advance resilient, secure and future-ready network ecosystem that supports India's digital growth. This presentation will be followed by one more representative, Mr. Rajan Mittal, who is the wireless head India at Nokia, where he leads the wireless technology initiatives and supports the deployment of advanced mobile network solutions. With extensive experience, Rajan in the telecommunications industry works with customers and partners to drive innovation, network modernization and the adoption of next generation wireless technologies. For now, please welcome Mr. Puri on stage.
So very beautiful pictures. Indeed, our airports are transforming. They are no more just a transportation hub. We have seen. So thank you for wonderful pictures and the transformation. So it's no more a transport hub. It is digital. It is more connected and more data oriented. Now, this digital transformation has to have some kind of scale, because we know the number of packs are increasing. It has to be secure to handle today's and tomorrow's threat, and it should be resilient, because these services need to work 24/7. We cannot have some kind of issues in these kind of infrastructure mission critical systems. Now, next 20 minutes we will be talking about how Nokia can help transform this aviation industry to make the networks more secure, more resilient, and more scalable. So we had a session yesterday where I talked about our wireline solutions, about IP MPLS, optics, and passive optical LAN. Today we will be focusing more on our wireless solutions, how we can assist our wireless solutions for especially airside, and some of the applications which can enhance the safety of airports. And of course, when I say airports, it is beyond airports, it is ANSF and airlines also, the entire aviation segment. Now, just for some of the people who are not there yesterday, my initial 2 or 3 slides will be repetitive, and then we'll get into the solution part. So, who are we as Nokia? Most of the people in industry knows Nokia as handset providers. So we are beyond handset providers. So who are we? So Nokia is pioneering a lot of innovations, and those innovations are the building block of today's technology. So we have a very long history of 160 years, around 26,000 patents, and those patents have evolved the life of the world. In fact, we have 10 Nobel Prizes also. We spent heavily on our technology, good 160 billion in the last 25 years. And last 160 years is beyond that. So if we see a very high level journey of Nokia, we were the ones who pioneered transistors. Transistors are the building blocks of integrated circuits, CPUs, GPUs. Talk about Shannon information theory. Anybody who works in communication knows Shannon theory very well. This theory is talking about the basic communication, how the data is transmitted, how the data is compressed, how it is recovered on a very noisy channel. The first orbiting satellite, which was I think 1962, was launched by Nokia, or by the technology of Nokia. First 2G call was conducted on Nokia solutions, not the Nokia handsets. The radio solutions, the code, the transport. It was in 1991. So we started this mobile communication journey. Talk about neural networks. Today everything is AI. Now AI works on neural networks. In 1998, I think if I remember correctly, we pioneered this technology, which is now the building block of AI networks. The physical infrastructure is getting choked. The fibers are getting limited. we are developing technology where you can maximize the usage of fiber. 2.4 terabit per wavelength. You can have multiple channels. You have C band, L band in optics. So there is no upper limit today based on our technology. Today we are working on C plus, L plus bands. So we are the pioneers of these technologies which are evolving in today's world. Now, as Nokia, we are a company of 20 billion, presence in almost all critical markets, 150 countries. We have our a unique advantage. We have our integrated portfolio, which is around 4G, 5G networks, IP networks, data centers, optics, fixed networks, and all this can help service providers like mobile service providers, internet service providers. But why we are here for an airport event? We have 2,600 references who are running their networks on Nokia. When I say mission critical, they use our carrier grade products. Our products have the capability to address all the use cases which are relevant for mission critical, and they have all the security features which are very, very important for mission critical. In India, we are around 18,000 employees. So India is a very strategic country for us. We have our sales offices in Delhi and Mumbai. Beyond that, we have a big R&D center in Bangalore and Chennai. Almost 8,000 engineers working day in, day out for all the new technologies. We have a manufacturing plant where we made in India products for both 4G, 5G and wireline products. So, what is Nokia doing in aviation? So as I said, in aviation, I believe there are three different segments. One is the airport, which serves as actually showcased very nicely. Then the second aspect is airlines, and third is ANSP. Now we have almost 100 plus references around the globe only for aviation. You see on the left top side, all the airports around the globe are using Nokia solutions. Changi Airport, and they use different technologies based on their use case and their KPI requirements. So Brussels is their Lufthansa Technique, their maintenance way is using our wireless 4G, 5G network so that they can coordinate all the maintenance work in their maintenance way. Helsinki Airport, Qatar, Taiwan is a new addition recently. It's a brownfield network for us. We replaced one of the incumbent OEM. And then on the lower side, we have ANSP networks like Australia, ENAV, which is a very good reference for almost 74 ATC locations within Italy. Then we have Ireland, Vietnam, and many more. But then we also work very closely with the associations, the regulatory bodies which dictate or which write the rules for this industry. If you can see, almost all the critical markets, we work very closely with the associations which basically define the rules of aviation industry. So let's get into the wireless solutions. So my colleague Rajan will just walk you through our solutions in wireless, and then I will take over for the quantum safe solutions in the next section. Over to you, Rajan.
Thank you, Rahul. Coming to the wireless solution. Thanks for inviting me, first of all. In wireless section, I would like to specify three key areas of airport. We see a land side area, the air side area, and the terminal side area. Now, to cover these areas with digitalized solution and use cases like these, we need to see the key use cases which are required for the airports in today's world. In India, we have to see that for these use cases, primarily like below wing, or asset tracking, or passenger bus areas, or marshal car, for example, are they having sufficient connectivity capacity to take the data towards the control center, command center, where it can be evaluated further. When we were discussing in Europe, as Rahul mentioned the references, we saw that there were challenges which I highlighted here, mainly because of coverage and capacity. So airside coverage is currently not sufficient enough. And it was evaluated in the European market that due to the Wi-Fi which was used mainly on the air side, and on Tetra network, which was used on the air side, that was not sufficient to cater to the requirements. There was congestion on the terminal side because the same Wi-Fi was used by passengers for the terminal use for other use cases. While still some of the operations were still manual, they were not automated. Safety, security and standardization is another topic which needs to be taken care when we are developing solutions for the airports. And herein we are coming in for a 4G, 5G private wireless solution. Along with this, we have also active DAS solution ideal for terminal use, where you can get in the operators and their service will be provided on the terminal side. And the third one is A2G solution, which is primarily to get the service in flight when the aircraft is in the air. Starting with private wireless solution, if you see this bubble, in the middle of the bubble you can see the 4G, 5G radios connected to the port. And here is the simplest architecture because this is 3GPP standardized. And it is proven well in the CSP domain these days also we have seen. And past 20 years we have seen this being running very well, catering to number of users, coverage as well as capacity needs. The Nokia solution is primarily based on radios which will be deployed on the air side in different bands which is allocated. They are connected to the core element which is in turn connected to the application server for those use cases which we want to implement on the air side or any other locations. To complement, we have devices also in picture because to get the data from these radios, you need to have ruggedized vehicle routers plus the antenna which will be mounted on the marshal cars. You need to have a ruggedized dongle so as to take the telemetry data from the aircraft and then put it towards the centralized location. Ruggedized handset to get the PTV calls and intercommunication can happen within the terminal, and ruggedized tablet for any operational or camera feed you want to see on those tablets. The second solution is active DAS. This is primarily meant for the terminal side where you want to have a single confined solution where you can bring in different operators. Like in India, we have 4 operators primarily, and then their feed can be transported into the terminal side and the passengers can avail the services from individual operators as and when required. The beauty of this solution is that it is zero loss with fiber connections. We don't rely on the passive cables which have more losses, and then also they take space out of those false ceiling. So what we are giving is a common infrastructure for voice and broadband, and then it is meant for both mobile service providers as well as private network which is maintained by the terminal operators. The third one is A2G solution. This is kind of being in the European market for last 10 years or so, and we have seen this in 35 countries in Europe already being established. It is in use. What it is we are deploying terrestrial network or land base stations, E-node on the land side between sector 1 to sector 2, and then the antennas, specialized antennas are pointing towards up, and they give the coverage to the in-flight aircraft. And there is an antenna which is located on the nose end of the aircraft, which receives the LT signal and it acts as a pipe to the in-flight passengers who want to avail the voice and broadband services. So this is a comparison was also done with the satellite service which we used to have, and it was seen that it has more throughput, lower latency, and it is efficient in cost also. In summary, I want to highlight the 3 use cases from the European market which we have given our Nokia private wireless solution, both 4G and 5G, and you can see the gates, airside terminal operations are currently on 4G in Vienna Airport. In Brussels, you can see the Marshall car having the connectivity, while here we have the good communication service also as a use case running. While in Helsinki, we have a de-icing kind of feature which is required to maintain the operations, maintain the aircraft running, landing and taking off. While on the rightmost side, you will see the A2G reference we have done in MIA recently with Sky5 Arabia, And then the second one is the emergency service network, which we have done with EE, now British Telecom, where we have deployed those LTE 4G, A2G nodes, and then service is provided to the passengers and as well as for the emergency purpose. Thank you. Next, Rahul will continue with the quantum safe networks.
Thank you, Rajan. Very useful solution for some of the very specific use cases where a wired solution is not possible. So quantum safe, it's a very new word for most of the people. Today we use our systems, our laptops for personal use. We use connect to banks, and we blindly believe the encryption, the HTTPS, what we see on the browser is safe. It is safe, no issues. But the encryption mechanism we use today, like ECC or RSA, they cannot be hacked. But going forward, when we have quantum computers, these algorithms, asymmetric algorithms, which are working on mathematical entropy, they will be hackable. For example, ECC, you can break the ECC encryption in 4 days. You can break RSA in 1 week. Now, is it happening today? No. You need specific compute power of a computer, of a quantum computer. You need approximately 1200 to 1500 qubits, logical qubits, to break a ECC or a RSA algorithm. Today, where do we stand? We have quantum computers with around 100 logical qubits. So we have some time, but the technology is moving very fast. So the logical qubits are derived from physical qubits, and there is a lot of error mechanism improving. So what I'm trying to say, that journey from 0 to 100 logical qubits took a lot of time, but the future journey from 100 logical qubits to around 1200, 1500 qubits, which is required to break these current encryption mechanisms, will not be very long. So once we have that quantum computer or cryptographic relevant quantum computer, that is the Q day for us. When the existing ecosystem of encryption will have threat. Now, yes, we are safe for 2-3 years, no problem. But there is another challenge. The bad actors, what they are doing today, they are harvesting the data. So for example, I'm logging to my Aadhaar site and I'm putting my Aadhaar number. If my Aadhaar number has relevance for next 3 to 5 years, they will harvest my data, the encrypted data, and they will decrypt it after 3 to 5 years. So any segment where the data is relevant for next 3 to 5 years, they will harvest it now and they will decrypt later. So the vulnerability threat is there today. So we have a 0-day vulnerability. That means if you want to make sure your critical data in a mission critical segment like airports or aviation is critical, you have to plan today. There are different areas in aviation where we see the data is very, very critical. Now if you see ATC, the communication between aircraft to tower or tower to tower, these are very critical data. It has to be secure. You cannot compromise that data. You talk about the aircraft talking for weather reports, for the maintenance operation, for telemetry data. Again, these are critical information. You cannot modify it. It will actually affect the safety of the passengers and aircraft. The personal data of passengers, like passport, like biometrics, all these things are there in the system. You have to save them. You have to secure them. And then, these are small things, but CCTV, they're all digital today. Baggage handling, aircraft information handling, all these things are critical. The airports are working 7/24. You cannot compromise the security of these aspects in airport. They are safe today, but are they safe tomorrow? That is the question. So we believe in Nokia We believe in defense in depth. Like every time you plan a network, we always plan a resident network, 1+1. This is my primary path, this is my secondary path, this is my primary server, this is my primary database. But security has to also be resident. You cannot secure or encrypt one layer of your entire ecosystem. You need to secure multiple layers. If you just encrypt your application layer, it will not safeguard you. You need to have security at multiple layers. So we have security solutions for all the network layers, which are the lower layers, like physical layer. We have OT and SEC on our optics boxes, which works on quantum physics or classic physics entropy. Now, what is entropy? Entropy is the complexity of the key. Now, the generation of key is very critical for encryption. Historically, we use encryption key on mathematical based entropy, where you can predict the key because those mathematical algorithms are very predictable. Going forward, for complex environments, and we have not talked about AI. So quantum computer with AI can predict those keys very easily. That is why you see the ECC or RSA algorithms can be hackable in weeks. So your entropy or the key generation mechanism has to be non-mathematical. And the new way is classic physics or quantum physics. So we have solutions where we generate the key or the entropy is classic physics or quantum physics. On physical layer, which is OT and SEC, so all the optics boxes support this entropy and encryption. Then, if your network is working on a routing ecosystem, then we have MACsec, which encrypts the data on layer 2. And then we have AnySec, which encrypts the data on layer 3. So along with application, you can have this add-on encryption mechanism, and these are available today. And the beauty of our Nokia solution is all these layers have a single key management system. So if you have optics, you have IP, you have layer 2, layer 3, multi-vendor environments, there are workarounds where you can encrypt and make your network quantum safe. Now talk about application layer today where we are. So there is an organization in US known as NIST. They write all the algorithms and they have come up with 3 different algorithms which are quantum safe, but they are not live. They are in testing phase and it will be live in next 2 to 3 years. So till the time those application layer post-quantum cryptographies are available, you have an alternative, you can make your network secure by our layer 1, layer 2 quantum safe encryption. We have products in IP, in optics at different layers. So there are specialized projects for access, for aggregation, for code based on your application, based on your KPI requirements. And let me tell you one more thing. All these boxes, what we are showcasing here, are having Nokia own chipset. What does that mean? Whenever you enable a feature or a specific encryption policy, it will not degrade the performance of the box. The latency of the box will remain as is. So your entire mission critical aviation network, if it is working on IP optics or fixed network, it is quantum safe and it is not affecting the performance of your network when you enable these kind of very CPU centric features. Our products are approved by common criteria which is in Europe and NIST, which is a US based organization for these kind of things. One of the network, one reference, this Vietnam happened last year. They said we want to make our ATC communication quantum safe. They are handling around 1 million of packs annually. And what they did, they swapped their legacy network with our IP MPLS network and made it MACsec ready. So all their applications tomorrow will be quantum safe whenever we have this threat. So, and of course, these kind of things can be written. You can have dual core and the latency, which is very, very important for some of the applications in ADC, like low latency. They are not hampered because, as I said, our IP, optics, and fixed network have our in-house chipset where we do all the encryption algorithms. So, To summarize, if you want to make your network modern, which is scalable, which is resilient, you want to monetize your network. I think I talked about monetization yesterday. If you want to make your network secure, and when I say aviation, aviation is not a simple domain. It has multiple, facets, multiple segments. We have solutions to address all those use cases relevant for aviation, be it airports, be it airline, be it NSF. Thank you very much. Any questions? I will be available at Nokia Group. Thank you very much.
That was technology on par excellence by Nokia, ladies and